Today I'm going to study VisJS physics. I think I'm going to try to implement on the project. I was accepted to nights and weekends, which is a good thing, obviously. And I assume that not sure if wood's the right way to put it, but that they would accept me because I was part of the previous one, but I wasn't sure because maybe they were just going to approve people that had something completely new, so I wasn't 100% sure, but now, yeah, I'm sure. So it's gonna start Saturday, I think. But obviously it doesn't change anything the way that I'm doing things here. So I'm gonna put some music and I'm gonna try to do this. Yesterday I was seeing if I could implement the dragging on the customization, but I think it's gonna be very annoying, so I'm not really sure. I think I'm gonna study physics first and then see if I study this later or try to make it happen later. And I was also trying to create a collapsible component, like something that allows me to collapse the customization div because it takes a lot of space, and I want to allow people to remove that. But it was quite annoying, so I decided to go with the simplest solution, which is just to create a button that hides the div, because I don't want to deal with this kind of stuff. I don't think it's that important. But now I have to keep in mind that in order to make this work, I have to make the position of this absolute so that it is overlapping the other div. Because the other way that I was doing, if you put the button inside of the div that has the CSS, then when you hide the elements, the CSS stays there, and it's not what I wanted. I just wanted to show the button when I hide the div. So I have to put the div outside of the class. I have to put the button outside of the div. And then, because of that, I created another div to wrap them both. But then the issue is I want the button to be on top of the other one. So the only way to make that happen is with the position absolute, I think. And the problem with that is that when I move this div, I'm gonna have to see if the button is gonna move. I think it's not gonna move because the position is absolute, so I'm gonna have to move both of them. I think it's not that big of a problem. Just use another ref here and then move again. So I think I'm gonna try to copy this tutorial here that I saw to see if it works. The code that I have there is from another tutorial, so. But I'm much more concerned with the physics. So the solvers are these ones. And if I remember correctly, I think that the first is the gravity solver that gets called, then I think is the nodes and then the edges, and then it calls a function called node moves, or move nodes, something like that. And that function is the one that applies the forces to the thing. And I think the way that they do it is the forces are the gravitational forces, and then the velocities are calculated by the other solvers. But maybe all of them have put stuff on the forces and velocities, but the way that they do it is by passing an object on all of them and keeping track of the forces and velocities on that object, and then using the object on the move nodes, I think. So I'm just thinking about trying to copy everything. I think that's what I'm gonna do, like copy all the classes and move them to my project and then try to implement. And I'm just gonna do the way that they did it with classes. Because before I was thinking about doing functions, maybe I'll do that at some point. But now I think that's probably better to just do it the way that they did it, because it's easier first, and then I can worry about the other stuff. And the thing I'm not really sure, I think I'm gonna use frame hook here outside of the use effects, and then inside of the use frame hook I just put a flag variable that is gonna be based on the use ref that is gonna determine whether or not the physics is activated, and it's gonna be based on the store, which is the physics enable thing. I think I'm gonna put this outside here. It's better because then I can just update this. And then I'll get the value from the store and I'll set the value. Actually, I don't need the ref because I can just use this, obviously. So no, but I think the other values come from the store as well, from current solver. Yeah, so actually I'm not gonna use the ref. I use the current solver and the physics enabled, and then based on them I select which ones it is. I think I'm just gonna try to copy everything, see if it works. Obviously I'm gonna have to change all the functions to work on 3D, but from what I'm seeing, I think it's not gonna be... Maybe the barn sets is the one that... The thing is, I haven't looked into the other ones a lot. I just looked into the barn set. So some parts it seems like it is not complicated, just add the X and Y. Just add the Z direction and do the same thing that they do for X and Y, but for Z. But I'm not 100% sure. So... you can remove this as well. Yeah. Also, the other thing I should do is probably remove all this stuff that is related to the selections from the other library, because I'm not gonna do it the same way, I think. And if I want to incorporate the stuff they did, I can just copy again from the library. So I think I'm gonna remove and see if anything happens. If nothing happens, I just will leave like this. It doesn't look like it did anything. So here, it's much nicer. I also added this stuff here. Just changed from the props to use the store, and now you can rotate as well, which is pretty nice. I think the reason why it doesn't like build the whole graph again is because it's just diffing and then updates the only thing that changed. So which makes sense. I think after I fix the physics, I'm gonna do a video, like a small video, and put it on Twitter. Same thing with this thing here, probably. Should probably remove from the thing as well. I think I should probably remove these values here and see if it's gonna break, because they're only referred to the layout, and obviously if I want to allow customizations for the layout, it's gonna be dependent on the store, so it doesn't make sense to receive as props. But I'm not really sure. I think nothing's gonna change because I'm not passing anything and it's using the default values from the layout provider. So I'm gonna try to remove them as well. Just trying to see what I can remove here so there isn't a bunch of stuff that is not necessary. It's probably also better to remove these functions here. Just thinking about these as well. I think I'm just gonna use the nodes and edges instead of using these visible edges and visible nodes, because this doesn't matter to me. I think the only thing that I'm gonna use from the other library is the function. I'm gonna see how they did it, so that, because they have a function that allows you to focus on the node that you select. And then when I use that, I think it's using the lookat function from three.js, from the camera. And I want to use that to navigate between the nodes with the keyboard. So I'm gonna remove the stuff first and see if it changes anything. What does this have to do with anything? I don't get it. I have no idea what this error is about. It's only happening when I delete the other stuff, and the other stuff doesn't have it, is not related to the mounted here. So I don't understand what's the problem. What the hell is going on? Oh, it's just because of the... It's still... Maybe the other function was calling this one? But it doesn't seem like... Because getting the state from the store, so... It might be because of the order of the... But even then, it's probably an error with the... Like the message itself, instead of being an error... Like it's giving the wrong message. That's probably what it's about, because it's complaining about this thing here. Yeah, I think I should do the props here, obviously, but yeah, I don't know. Yeah, now is working. Maybe I deleted something and I didn't see. Yeah, I have no idea what's going on there. I'm gonna try to remove all these props as well. I'm not using. See if it breaks anything. Hmm. The problem with this one is that I'm gonna have to see on all of them. Or maybe I should do that. Just see where the layout type is used. Or label type. This is another thing that I have to think about. But I think I'm gonna leave this like for very like way down the line. Which is to figure out how rotate the label as you rotate the scene. I think the way you do that is by using Euler, the Euler class, because I saw on the other project, but I think it's not that big of a deal. I don't understand why. It looks like it is not used on any of them. So I'm just gonna remove and see if anything happens. Maybe I should remove these functions now as well. Yeah, I think it doesn't matter, so I'm just gonna remove everything. The size might fuck up the other stuff, so I think I'm gonna remove the rest of the things first, and then I'll remove the size. Maybe I can remove this thing here as well. Yeah. After I clean everything up, then I'm going to open the other VisJS project and then copy the functions. But I wanna clean everything up first. There's a lot of useless stuff. I think now I'm going to see if I can remove the sizes one. I'm gonna remove here first. Because I think now I'm using radios on the node. Yeah, so this stuff doesn't matter. But I think I'm gonna leave this function here for now, this file, so that I can look at later to understand the layouts more. But maybe it's not useful as well. I think it's probably a better idea to just, because the layouts is just gonna be an algorithm that takes the nodes and edges and then calculates the positions in order to structure the layout. So I think I don't need the graphology as well. I think at some point I'm gonna have to spend time studying how the layout algorithms work and then try to figure out if there isn't already an implementation in 3D, if I can figure out how to implement one in 3D, then get the algorithms and implement the algorithms directly instead of having the layouts from the libraries. I think that's much better, and it removes a lot of this stuff that it's kind of unnecessary for what I'm doing. The only question is, at what point should I do that? I think this is the most challenging thing to figure out, because I have to study all the other stuff. So yeah, I'll leave this for now, and then I think after I have at least one form of visualization and I try to use it, then I'm gonna see. Then I'll think about deleting this stuff, but from the code now I'm gonna delete it. I think this one I can delete. Yeah, this visibility file. So let's see what else. The thing that I don't know about this one is that it might be necessary in the future, but I think I should just delete it and then I'll think about this later. But I know that some of them I think are necessary for the graphology layouts. Well, I should be testing this as well. So let me test first all the layouts, then I'll delete. Yeah. But maybe it's not the layout directly. I think it's just this. So it works. Okay. I think this data also is irrelevant, but it might be used on the layouts. Okay. Fill is necessary as well. Oh, the other thing that I have to do is figure out the arrow. Because I remember I commented out the arrow graphics because it was all messed up on the values. But I think I need to figure that out as well. That one I think is important because I think it makes a lot of difference in some visualizations to know, to have the direction, obviously. But probably the physics is more important, I think, first. Then I'll figure that out later. Obviously, at this point, I would like to be already building the other stuff, like the compilers, and working on the other part, but I think I have to finish this first. I'm not gonna be able to start the other one until... I'm watching some videos, but I started working on the other stuff until I have this one figured out, I think. Because then once I figure it out, I can just remove from my mind and free space. Should completely focus on the other stuff. Hopefully. Oh, the other refactor that I have to do is to move the nodes and edges through. Because I'm putting a condition for nodes and edges outside, just see if the nodes and edges exist, and if they exist, then I render the graph component. If not, I don't. But I need to move the logic inside. So what else? Maybe here I should put, instead of size, I put radius, and then I put the value based on the radius of the group. I think I should do that. Because these are the new nodes that are updated, are created, should update the thing. I'm not sure if it's necessary because I'm probably gonna change the values inside of the mesh itself instead of changing on the nodes. So you would just should have on the two different places in case I need to change on the node itself. Because I think on the first time, I have to remember to pass the node radius as a part of the nodes and edges objects from outside. But as long as I remember to do that, then it's fine. And if I forget, then obviously it's going to be visible because all of them will have the same size. So I think it's only going to matter because I don't think I'm going to want to control the size of the nodes. But maybe I will, actually. But if I do through the customization, then it's going to be directly on the mesh as well, I think. So it doesn't matter that the nodes don't have the size. The object doesn't have the size, and the meshes do. It's probably gonna go. I have to spend more time thinking about this as well, but I think I'll do it later. Because I don't understand why I have this thing here as well. Just passing everything, pretty much. I'll think about this stuff later. And continue to remove this stuff. Yeah, I think the easiest thing is gonna be to see if I just switch to receive the nodes and edges instead of the visible ones. I think the only benefit of using the other ones is the use memo thing, but I think it's not that big of a deal. This is the problem, though. I'm gonna try like this, then I'm gonna try to comment this out, to see if it's gonna work. It doesn't make a lot of sense to update them with the same, obviously. But if I don't update, then I think it might be a problem because it doesn't re-render the graph. And then it doesn't show anything. But I think it doesn't matter because I'm just setting everything through the meshes and then based on the mounted variable as well. So it doesn't matter if I do this. But I think I'm not 100% sure because when I was trying to change everything there on the layouts, it wasn't showing at some point and I wasn't sure what was the problem. So I just prefer putting this first, I think. Yeah, it doesn't show. I think it's because you don't set the state and then it doesn't render again everything. But it makes me think that there must be a way to do it that is gonna be better. Because I don't need this, like I don't need to set them again, obviously. From the point of view, because I'm adding everything to the nodes here. But I think it doesn't matter that much, so I'm just gonna leave it like this for now. Let me see these ones first. It's probably because just of this thing here. It's some weird thing that I don't understand that's going on. I think it has to do with this star. I think that's the only explanation. The Zustan star. It's something that happens on the React state that fucks up the thing there, but I don't understand really well. Whatever. I suck. Yeah, much better. And now I'm gonna study the physics. I was gonna see if I forgot anything here. I think this one is used on the camera. Like this one. Yeah. So now what I'm gonna do is see if I can put the use frame hook here instead of this one. Or I can put it on the other, I can put it here. And then I just do the same condition I did there. Here. I can put it on the same one. Hmm. Which one is better? Because obviously the physics is gonna be dependent on the nodes. So I think three things that I need is the nodes and edges and the physics object here from the store. So I'm gonna pass this object that I'm gonna get from the store. And then I do some conditions and pass whichever is the selected one based on the current solver, which also comes from the store. So I pass these three things to the... So maybe the first thing that I should do is create a folder for the physics. I have a little bit of a headache, so my head's hurting a lot. I might stop soon. But I want to spend at least some time studying the physics. I wonder if there's a way to see every place that this file is used. See if I can delete it or not. I'm just gonna delete and see what happens. Hopefully it doesn't break everything. Yeah, fuck. Or maybe it's just on the exports. See this. Ah, fuck it. I think I'm gonna delete this thing here now. So I'm probably gonna do what I said. We just study the algorithms separately. As long as they work now, I don't think I care that much. And I can study them separately later and implement. Yeah, nice. So the first thing that I'm gonna do is just create a physics thing here. Oh, the other thing that I'm thinking about, that I was thinking about, is the selection. I have to understand how they do the selection as well. Because I think I'm gonna have to change the dragging event, because it might be related to the physics. That's the problem. But maybe not, actually. Yeah. So I think I have to see, like, how does the move nodes function works. So the order is the gravity solver first, the nodes, and then edges, and then this function here. So maybe I'm just gonna write this down here. So it's gravity first, and then for each one of these, they use the solvers. A lot of them use the same solver, so. So I'll do the one that uses the most, which is these ones. This one is very simple, it's just adding forces there for the gravity. And it accepts the body of the thing, of the network. Just here, this body, initialization. And then the physics body, which is the thing, an object that initializes there. Maybe I should do this on SkyDraw as well. I think I will leave this one on the object, and then I will leave the... So these are the default options. And the physics body is this object here. So I think I'm gonna put this on SkyDraw, so I remember. But it's pretty much... And also from some stuff I've seen here, I don't understand why they do... Like, it seems like there's some things that they do that don't make a lot of sense to me. Like, they are not necessary from... Also, I have to see how this color picker works as well. Because I was thinking about something that I have to... Yeah, I'm gonna implement a lot of stuff with colors, so I probably should spend some time, but probably not now. So let me focus on the physics first. So they accept the physics body and the options that come from this here, which is the default options here. And then based on that, so let me see if there are the options are, this is right, I wrote down here, I think. So in which one, each one of them is gonna be the options from the thing, from the class, physics engine class. Which is this object here inside of this thing here. So the gravity solver is gonna receive this object in the Barnset case. The body, which comes from the network, which is the other object, and the physics body, which is the object there. And then based on that, it's gonna just calculate the things here. So what I don't understand is why pass the object. But maybe it makes sense because... but I think each time that they change the simulation, they're gonna do everything again anyway. So it doesn't make sense to share. It would make sense if you share the object between all of the solvers. So you're just caching the state for sharing between solvers, but I think that's not what they're doing. But I guess it makes sense because it's probably just like a small thing. It doesn't matter that much. Because instead of passing the options, you could pass the values themselves. But also, maybe you could loop over the nodes instead of looping like this. And then you get the ID from the node. I guess this is the thing that I didn't understand. Because you can just loop over the nodes directly, and then you don't need the indices here. Because when you map, you have the indices as well. So it's probably just because of the data structure of the node that they're expecting to receive. But for my case, I think I can just loop, I can pass the nodes and I can loop over the nodes and just get the ID for each one. And it's probably because nodes is going to be an object on the thing, yeah, the way that they did it, so it's different. But also you can just call the object.value. So when I was thinking about doing with nested objects for nodes, each key of the object would be the ID of the node, which may or may not be equal to the label. And then based on that, you can loop over the nodes based on object.values, which you just get the value, which is the object. Like it's going to be a list of the values of the thing, and then the index of the iteration is going to represent the ID of the node. So I also think if you have objects, you don't need to pass this value here. But it's just a small thing, so it doesn't matter that much. So, but pretty much the only thing that it does is just calculates the distance and then adds the force, which is going to be this delta x and delta y times the gravity, which comes from the object here, or divided by distance, or 0. And the distance is obviously... So the only thing that I will have to do is just add the dz here, I think. So I think that's the easiest one, and then it adds the... I think this is the reason why they pass as an object, because then you can add, and then you're gonna use the same object on the other solvers as well. I think that's probably the reason why it's better to pass as an object at the options. But maybe not. Yeah, if this physics body forces, which is just the physics body. And then I think that on the other ones, it also uses these forces here. So the hardest one to understand, I think, is the nodes solver, I think. I don't remember really well. Because I started studying by with the barn suts one. So it's gravity first, then nodes later. And the nodes is the barn sut, so is this one. And this is slightly complicated because as far as I understand now, the way that it works is it separates the space into squares and then it puts each node into a square and that creates a tree. And then based on the tree of nodes, it updates everything, and that's faster than if you would calculate all the nodes, because I don't know exactly like precisely why, but I know that the time there that they talk about is that one would be O(n) to the power of 2 and the other one is O(n) log n or something like that. So it's faster. It's much faster than just brute forcing, like updating everything. But it gets very confusing here. And this is the one that I'm not really sure if, like, how I'm gonna translate to 3D, or if it's just to add the DZ here as well. Like, just do this. And then add here. And then just leave the rest the same way. So the main function that it calls is this one, and then this creates the tree, and then it uses the tree on this one. And this, it updates the forces, get the contribution force for all of the branches. I think this is the biggest issue that I was thinking about, because here I think it's northwest, northeast, southwest, and southeast. So I think the way that they did it is for 2 dimensions, and I think this is the problem. It's like, because if as soon as you have 3 dimensions, then I'm not really sure how to separate this thing here to make it work. So and the other solvers I didn't spend too much time looking. I think the Spring solver already spent time looking before when I was doing the physics with Pixie.js. It's not very hard as well. The only hard thing to understand here is that they create another node to break down the edge in case you put another option for the edge, because it creates a Bezier curve between the nodes and that makes the edge curvy. And the way you do that is by adding these extra nodes here. So this part is kind of annoying as well, because I'm gonna have to remove this, I think. Or maybe I'll just leave it like this and then I'll see how to make work. I'll be right back. think I'm gonna spend like 20 minutes here or something like that. It's not, I don't have a lot of headache, but I can feel that it's getting like worse. So I think I'm gonna take a break and then I'll probably work on this on off stream. I had this on and off for the past couple of days and I'm not sure why. And it comes out of nowhere as well. The other thing that I thought about just now is that I can look at the data structure that they use for the nodes and edges. And based on the data structure that they use, I can see if I can get away with not changing anything here. I think I have to try to make it work as fast as possible. So the biggest thing to change would be obviously the z direction, but I can just add there. It's not complicated. And then the issue is the points. And so I have to see the data structure that they are using, and then I'll think about it. I think this comes from another file that exists on the project here. Examples, utils. Yeah, I think it is this one. So the nodes have an ID. Is a list of IDs and labels, and the edges is just from and to. And from is just the ID, maybe. So maybe I can get away with just passing nodes and edges there. So the hardest one to understand is the Barnes search solver. I think I'm gonna look, like, superficially look into the other node solvers because I think that they might be they're probably gonna be the hardest ones to understand. The central gravity is very easy. And the only thing that I have to do after I do that is see what it accepts there. I could just pretty much copy everything, I think. And then I get the values from the store and then pass them to these things here, and then I just modify the function so that it works on three dimensions instead of two. So I'm gonna copy the files there. Yeah, I think I don't need to copy the physics engine one, so the biggest question, the biggest challenge is to think about what is the correct approach, where to initialize everything, and if it does make sense to just copy the classes and not refactor them to work just with functions instead. So I have to see if there is a method that disposes everything on the physics engine. I think I'm gonna superficially look for the nodes solvers of each one and see which one is the easiest to implement. I think I'm gonna start with the barn sets actually, because I remember from when I used VisJS to study some other stuff, the barn set seems to be the one that is the best one to visualize. So I think I'm gonna have to study that one first. Maybe I should read this article here that I saw from a video, and I think I'm gonna research more as well. But the biggest challenge is how to translate this into 3 dimensions. Because this one seems very easy to understand how it works. So I have to clarify how to split the trees based on 3 dimensions. Because it's not going to be squares, it's going to be cubes, obviously. Maybe not obviously, but maybe it is cubes, so... I think this is a difference, big difference as well, is that they use events and I'm not using events, so they probably don't have a function that disposes everything. So the question is it necessary to dispose? Maybe I can use the use memo hook as well to, or use callback. But I think, I'm not really sure if use callback works with classes. I think it only works with functions. But I could initialize the functions instead of the use callback. Maybe I don't need the classes, I can just get the functions and then just do the flow of if-else statements based on which solver it is, and then I just got the functions. Let me think about this. This one is also complicated to understand. But it's just getting the values from the object. So this is another question. Where should I initialize this thing? Should I put it on the store? Should I initialize on the component? Or is it even necessary to initialize this? Can't I add this stuff on the node itself? I think probably the best thing to do is to go over off stream with this draw and then try to draw the connections between everything. Because I need to understand how all the solvers are gonna connect with the object and see if I can, instead of using the object, I can just put the forces on the nodes based on the functions, and then I get the functions, create the flow of if-else based on the which solver it is, and then I just change the nodes through the solvers. And that happens inside of the use frame. I think the other ones don't have any function to dispose as well, the class. So I think it doesn't matter that much. I think it would matter only if the classes had event listeners, like attached to DOM elements instead of attached to the object from the network class. And obviously I'm not going to use the events, so I think I don't need to remove anything. I think all of them work on the same way as well. They just get the object there, the options, the body. Then they add stuff to this thing here, and then they use this to calculate the position and velocity, the forces and velocities of the nodes on the move nodes function that comes from this one. So maybe I don't need the classes as well. Maybe I can just get the functions. The issue might be the reference to the values. I need amounts and amounts, so and again is looping over the nodes and getting the nodes. Also here is doing a nested loop and getting the 2 nodes. Loop from I overall, but the last entry in the array. J loops from I plus 1 to the last. This way we do not double count any of the indices. Processing forces between nodes. Here comes here. Yeah, this one is not gonna be hard. Just looking at this. So I think for this one I can just change can just add FZ here. It's just based on the distance between the 2 nodes. I don't understand why though. Like, why use these 2 nodes? As far as I understand, it's using it's looping over the nodes and then it's getting the 2 that are connected in the indices. And then is adding the forces to them. And it seems very bad because then obviously it's not going to scale well in 3 dimensions because I'm going to have to add another loop. It's just going to be very inefficient. So I have to... I'm going to ask ChatGPT... Oh, this is this one, not this one. I'll ask ChatGPT and maybe search on DuckDuckGo. Yeah, I want to see if this is just from VisJS, like they invented this, or if it's a well-known algorithm and this is just the implementation of it. Because then obviously you can search if there is a 3D version and how it looks. And this random number I figure out is just to move the nodes in case they overlap, I think. So they use this library to create an RNG, and then based on the RNG they move the nodes. Yeah, here. And I have 100% overlapping, yeah. So this one also seems pretty easy to, because obviously it's gonna be similar to the other one. But I just have to understand this. What's gonna be hard is trying to understand why the connection has to be like this. And if I can figure out a better way to do it. Oh no, they are connecting all the nodes when they loop over both of them, when they do the nested loop. They're not connecting just one with the other next to it, I think. But maybe not. Because why not only loop once and then make the index of the other one plus the other one? So just doing I plus 1 on to get the other node. It looks very simple as well. This one extends Barnsat. And this one's probably complicated as well. I don't understand why this extends Barnsat, because it seems like it is not using. Oh, because this one doesn't have the solve method. That's why. So I think it's just the same as Barnsat, but it uses this function instead of the Barnsat ones to calculate the velocity, calculate the forces. So all of them seem like they are not that difficult. And yeah, the only point of having the class is the instances of the object, which might be a problem. But if I'm doing things based on the store, I don't see it doesn't make sense for me to make the classes, I think. I think it's much better to just get the functionality and then I put on another file. And then instead of using the object, I can just pass to the function. I think that's what I'm gonna do. And it obviously is gonna come from the store. Maybe not the physics body. The physics body can be can come from the components. But maybe it's better to... I guess this is the question that I have to answer, is whether or not the physics body is necessary. What is the best way to answer this? So the other function, I think the two main functions that are slightly confusing to understand is the barn set, and the other one is the move nodes. So I have to understand both of these, and I want to know if the physics body is necessary, like having the object is necessary, or if we can just put the forces in the node itself. The forces and the velocities, and then I don't need the thing. Because if that's the case, then I can just use the functions. I put the functions on the file, then I pass the nodes and edges. Nodes are edges, and then put the stuff on the nodes and edges. It doesn't seem like it's gonna be very hard to do it. So I think what I'm gonna do now off stream is just create a, because my head is hurting, so I have a headache, so I'm just gonna open SkylyDraw and I'm gonna do a flowchart of this thing here like I did with the other things. And I'm gonna try to see if the physics is connected, if the physics body object is necessary. And I'm also gonna I'm just gonna create a file that has all the functions. And then maybe I don't need the folder as well. I just put all the functions in the same file from here, and then I put them somewhere else. And then I'm gonna get those functions, and I'm gonna create another function here. I have to think, this is another thing I have to think about, is whether or not, I think it might be better to just put it inside of here. But it's just like, I'm gonna get the values from the store, and then I put if current solver, or I do a switch. Current solver. And then based on which one it is, I call the functions the same way that it is there. And then inside of here, I'm gonna put a condition to see if physics is enabled. And then I put the switch inside. And I'm probably gonna do, yeah, it's gonna be the value from the store actually. So I think it might be better to do it here because I'm already using the uses frame to do this stuff here. But I'm contemplating whether or not, because I'm not using the config star here. So if I import and I use, might be slower, but I think it doesn't matter that much. Also, I have the node IDs here. I remember I left this here because I thought it might be useful, even though I'm not using now. Might be useful in the future, so maybe I'll pass these ones because they get the indices there. So yeah, I don't know. But it seems like it shouldn't be that hard. The biggest problem will be if there is something with React in the instances of everything, like if... But I think if... And also the how to translate the barn set into 3 dimensions. I think that's the other big problem. But it seems very easy to... The rest seems very easy. So I'm gonna read this stuff here with the text-to-speech, then I'll stop here. And I will do this stuff that I said off stream. And probably come back tomorrow or Sunday, because tomorrow there's the event from Buildspace, the kickoff, I think. Which they're probably gonna talk about how it's gonna be.
The Barnes height algorithm. Tom Ventimiglia and
I
Kevin
was
Wayne.
gonna spend more time today, but I think it's not a good idea to force. It's probably better to rest. And
The crucial idea in speeding up the brute force and body algorithm is to group nearby bodies and approximate them as a single body. If the group is sufficiently far away, we can approximate its gravitational effect.
I think it doesn't work on websites that don't have HTTPS.
The Barnes height algorithm. Tom Ventimiglia and Kevin Wayne. The crucial idea in speeding up the brute force and body algorithm is to group nearby bodies and approximate them as a single body. If the group is sufficiently far away, we can approximate its gravitational effects by using its center of mass. The center of mass of a group of bodies is the average position of a body in that group, weighted by mass. Formally, if two bodies have positions x1, y1, and x2, y2, and masses m1 and m2, then their total mass and center of mass, x, y, are given by m equals m1 plus m2 x equals x1 m1 plus x2 m2, my equals y1 m1 plus y2 m2, m. The Barnes height algorithm is a clever scheme for grouping together bodies that are sufficiently nearby. It recursively divides the set of bodies into groups by storing them in a quad tree. A quad tree is similar to a binary tree, except that each node has 4 children, some of which may be empty. Each node represents a region of the two-dimensional space. The topmost node represents the whole space, and its 4 children represent the 4 quadrants of the space. As shown in the diagram, the space is recursively subdivided into quadrants until each subdivision contains 0 or 1 bodies. Some regions do not have bodies in all of their quadrants. Hence, some internal nodes have less than 4 non-empty children. Each external node represents a single body. Each internal node represents the group of bodies beneath it, and stores the center of mass and the total mass of all its children bodies. Here is an example with 8 bodies. To calculate the net force on a particular body, traverse the nodes of the tree, starting from the root. If the center of mass of an internal node is sufficiently far from the body, approximate the bodies contained in that part of the tree as a single body, whose position is the group center of mass and whose mass is the group's total mass. The algorithm is fast because we don't need to individually examine any of the bodies in the group. If the internal node is not sufficiently far from the body, recursively traverse each of its subtrees. To determine if a node is sufficiently far away, compute the quotient S, d, where S is the width of the region represented by the internal node, and d is the distance between the body and the node center of mass. Then, compare this ratio against the threshold value theta. If S, d less than theta, then the internal node is sufficiently far away. By adjusting the theta parameter.
So I think that I was confusing there. So it's probably just as easy as adding the z direction. It seems like the north, west, and the other options is just the branches of the tree here. So each node has this 4 different branches, and then it's based on the mass and the distance of the nodes. So the only thing that I have to do is add the z direction, and then it's gonna work, I think. Hopefully.
We can change the speed and accuracy of the simulation. We will always use theta equals 0.5, a value commonly used in practice. Note that if theta equals 0, then no internal node is treated as a single body, and the algorithm degenerates to brute force. Constructing the Barnes height tree. To construct the Barnes height tree, insert the bodies one after another. To insert a body B into the tree rooted at node X, use the following recursive procedure. If node X does not contain a body, put the new body B here. If node X is an internal node, update the center of mass and total mass of X. Recursively insert the body B in the appropriate quadrant. If node X is an external node, say containing a body named C, then there are 2 bodies B and C in the same region. Subdivide the region further by creating 4 children. Then, recursively insert both B and C into the appropriate quadrants. Since B and C may still end up in the same quadrant, there may be several subdivisions during a single insertion. Finally, update the center of mass and total mass of X. As an example, consider the 5 bodies in the diagram below. In our examples, we use the convention that the branches, from left to right, represent the northwest, northeast, southwest, and southeast quadrants, respectively. The tree goes through the following stages as the bodies are inserted. The root node contains the center of mass and total mass of all 5 bodies. The 2 other internal nodes each contain the center of mass and total mass of the bodies B, C, and D. Calculating the force acting on a body. To calculate the net force acting on body B, use the following recursive procedure, starting with the root of the quad tree. If the current node is an external node, and it is not body B, calculate the force exerted by the current node on B, and add this amount to B's net force. Otherwise, calculate the ratio SD. If SD less than theta, treat this internal node as a single body, and calculate the force it exerts on body B, and add this amount to B's net force. Otherwise, run the procedure recursively on each of the current node's children. As an example, to calculate the net force acting on body A, we start the root node, which is an internal node. It represents the center of mass of the 6 bodies A, B, C, D, E, and F, which have masses 1, 2, 3, 4, 5, and 6 kilograms, respectively. The force calculation proceeds as follows. The first node examined is the root. Comparing body A to the node center of mass, white dot, the quotient SD equals 143.1 greater than theta equals 0.5. So we perform the process recursively on each of the root's children. The first child is body A itself. A node does not exert force on itself, so we don't do anything. This child represents the northeast quadrant of the space and contains the center of mass of bodies B, C, D, and E. Now SD equals 5062.7 greater than theta, so we recursively calculate the force exerted by the node's first non-empty child. This is also an internal node, representing the northeast quadrant of its parent, and containing the center of mass of bodies B, C, and D. Now SD equals 2566.9 less than theta. Treating the internal node as a single body whose mass is the sum of the masses of B, C, and D, we calculate the force exerted on body A, and add this value to the net force exerted on A. Since the parent of this node has no more children, we continue examining the other children of the root. The next child is the one containing body E. This is an external node, so we calculate the pairwise force between A and E, and add this to A's net force. Having examined all the siblings at this level, we move on to the next sibling of the parent. This brings us to the node containing body F. Since it is an external node, we calculate the pairwise force between A and F, and add this to A's net force. Text, adapted from KISS 126, Barnes Height Galaxy Simulator, 2003 diagrams, Samsonite Drafting Company, 2011.
I'll have to read this again, just and think about it a little bit more, just see if it's not necessary, because it also at the same time seems like it's based on the region of the node. So I think it should work if I just put the z, but then it's gonna be cubes instead of squares, and it's gonna calculate it's gonna create these 4 quadrants or 4 children for each node, and then it's gonna calculate based on that. Yeah, so that's what I'm gonna do now off stream. I'm gonna create the flowchart first, and then after I create the flowchart, I'm gonna put everything on a file, and I'm not gonna use the classes, I think. Then I'm gonna think about, yeah, the main thing that I have to solve is whether or not the physics body object is necessary. This thing here, and also understand more how this one works and the Barnes set one works. I think after I do that, then the rest should be easy, and maybe the The Spring Solver maybe is hard as well because it might not work with this one. But I'm gonna focus on this now. And next time, I'm obviously gonna continue to do this stuff. And once I'm finished with the physics and it works, then I'm gonna move on to the compiler and interpreter things. I think that's the last thing that I'm gonna do. Besides maybe I will think about whether or not the arrows are, if I should. Also, I have to fix this thing as well. So maybe, yeah, I'll do these things first. So I'll fix the physics, then work on I think I'm gonna work on the dragging this thing first, so I can move around, and then I'll work on the arrows. And after that, I will start the compiler and interpreter. So I'm probably gonna come back 2 days from now, but maybe only 3 days from now. I don't know. And continue to do this stuff. So